Everyone, welcome to the discussions on the past year question. This video we shall discuss about the further maths year 2023, May-June, paper 11. Okay, so let's take a look at the question number 1. Let's A to be a 2 by 2 matrix given as this. Prove by mathematical induction that for all positive integers n, 2a power n is equal to the given form. Okay, so we need to use the mathematical induction to prove the relationship here. So the first thing is that the first step, we just need to let n equal to 1. Then I have 2a to the power of 1 is the same as a 2 multiply of the 3 of this. Then if you expand it inside, then multiply inside, then you get this one is exactly the same as the given form. This one is a 2. Yeah. Okay. So this one is the same as the form that we have over here when the n is equal to 1. Okay. So this one is true for n equal to 1. Now we assume true for n equal to k, which is 2a power k. It will be related as this. Okay, so this is the second statement. Now we want to go for the third statement. When n equal to k plus 1, when n equal to k plus 1, what are we expecting? Okay, we're expecting to make the k here become k plus 1, this one become k plus 1, this one become k plus 1. Okay, but however, we need to prove. Okay, so how are we going to do it? So it will be 2a power k plus 1. It will be the same as a 2ak multiplied by a power 1. Since the 2ak, the result that we have here, we copy down. So this one, it will be like this, 2 times 3 power k is 0, 3 power k minus 1, 2. And the a is given as 3101. So if you expand them properly, you will get 2 times 3k plus 1. And you get a 0 here. Then you get this one as a 3 times k plus 1 minus a 3 plus a 2. Then this one, it will be a 2. So simplify them. You get this as a 2 times the 3 to the power of k plus 1. Then this one is 3 power k plus 1 minus 1. Okay, so you have successfully shown the relationship, because what you need to do is just show that when the k n is equal to k plus 1, all these will become k plus 1. So you have successfully shown this. That means this one just say that it's true for n equal to k plus 1. Okay, that will be your third statement. So your last statement, conclusion. By the BMI, so BMI is a short form of a proof by mathematical induction. Okay, that means 2a power k is equals to the power n. Is given as 2 times 3 power n. Three power n minus 1, 0, and then 2. Okay, for all positive integers n. For all positive integers n. Okay, just like that. So this will be the answer for the part A. Now we move to the part B. Find in terms of n the inverse of a power n. So the a power n, now what we are having here is actually the 2 of a power n. We want a power n, so means I need to divide everyone by 2 over here. So by right, the a power n is supposed to be written as 3 power n 3 power n minus 1 over 2, 0, and then 1. Okay, so the a power n inverse, it will be 1 over the determinant. The determinant is 3 power n. The determinant is only 3 to the power n only. Then this matrix we swap. This matrix we put negative in front. Okay, so this is the answer already. Actually, you can just leave it like that. Or if you don't want, you can multiply it inside. Then you will get this one as a 3 to the power of negative n. And this one, it will be 1 minus 3 power n over 2 power over 2 multiplied by 3 power n. Okay, so depends on how you want to leave it. 0 and then 1. Okay, so this is the answer already. Done. Okay. Okay, now we look at question number 2. The cubic equations given as this has a root alpha, beta, and gamma. Find the value of alpha square plus beta square plus gamma square. So first of all, I just need to list out alpha plus beta plus gamma is a negative 4. And I know that alpha beta plus alpha gamma plus beta gamma is equal to 6. Then just use the formula alpha square plus beta square plus gamma square equals alpha plus beta plus gamma square minus the 2 of alpha beta plus alpha gamma. So this one, it will be a negative 4 square minus a 2 times 6. Okay, so if you press a calculator, it will be a 16 minus 12 and you get a 4. Just like that, done. And now we go for the part B. Use the standard result of the list of the formula MF19 to show this equals to such form, and A and B are the constant to be determined. So what you need to do over here is to, first of all, I will expand them in this way first, alpha square. Then I have alpha square plus 2 alpha plus r square. Then beta plus r square, I will get beta square plus, oh, I forgot there's an r here. This is a 2r alpha. This one is the r square. This one is a 2r beta plus the r square. And for the gamma of r, so we have a gamma square plus the 2r gamma plus the r square. Okay, so just need to take the 1, 2, 3, add together. That means this whole thing, the series of all this add together, alpha plus r square plus the beta plus r square plus the gamma plus r square is equivalent as the 3 of them here add together. So if you add all them, add all up together, then you will get alpha square plus beta square plus gamma square plus the 2r alpha plus beta plus gamma plus the 3r square. So we already have the answer for alpha square, beta square plus gamma square, and also alpha plus beta plus gamma in part A. I just need to use the result. Then I have this as the 4, 4. And then alpha plus beta plus gamma is a negative 4. So this one is a negative 8r plus 3r square. So I just need to use a formula from the formula booklet MF19. Just need to look for this. Okay, this is the formula that we can find in the formula booklet of MF19. Same thing happened for this. And n plus 1 to n plus 1 over 6. Okay, so this is the formula that we can find. just apply them inside directly. You get this one as a 4n minus a 8 of n plus 1 over 2 plus the 3n n plus 1 2n plus 1 over 6. Then factorize the n out. Okay, so factorize the n out, and then you will get this one as the 4 minus the 4n minus 4. Then this one you have 3n squared plus 2n squared plus 3n plus 1. Over 2. Then after that, simplify the whole thing. Then you will get this one as an n squared minus the 5 over 2n, then plus a half. Therefore, your A is a negative 5 over 2, and your B is a half. Okay, so that will be the answer for this question number 2. Get question number 3. A. Use the method of differences to find the series of this in terms of n and k, where k is a positive constant. Okay. So what you need to do over here in order to do use the method of differences, first of all, we can just treat this as a partial fractions. We try to decompose them. Remember that the k is a constant. So what you can do here is that we split them into the kr plus 1 plus the b over the kr minus k plus 1. So when before that, we need to do this. This is a kr minus k plus 1 plus the b of the kr plus 1. So when the r is equals to negative 1 over k, so you have 1 equals to negative ka. So your a is negative 1 over k. Then when your r is equals to k minus 1 over k, how do I get this? How do I get this value? Actually, you just need to let this thing equal to 0. Then you can get this answer. Okay. Then substitute in. Okay. Then you will get 1 is equals to, this will become a 0 now, plus the k minus 1 plus 1. So it's a kb. Then I get the b is equal to positive 1 over k. Okay. So once you have the a and b already, just put them inside. Split them as a partial fractions. That means this series, bit long, kr plus 1, kr minus k plus 1 can be separated as, I will take the 1 over k out, then I will put the positive in front, then the negative at the back. I'll put it like this. Okay. Then since the k is a constant, actually I can bring the constant out. Then just replace k r equal to 1 inside. If I put the r equal to 1 inside, then I will get this as the 2 minus k. If I put 1 inside, sorry, if I put 1 inside, I will get 1 minus 1 divided by 1 over k plus 1. Then when I put r equal to 2, okay, then you have a k plus 1. Then you have a 2k plus 1. Okay. Then when I put the r equals to 3, put the r is equal to 3, then I have a 2k plus 1. minus 1 over the 3k plus 1. I will write down vertically. Write down vertically. And this one is I no need to list out so many things because once I list out the first three terms and I can see the pattern, you can see that this pattern they can cancel it in this way. Okay, they all can cancel in this kind of they can cancel it directly like this. So means the remaining part I just put a dot dot dot, and then I just need to list out the last two. The last two. This will be the case where your R is equal to N. This will be the case where your R is equal to N minus 1. So when your R is equal to N, then you will get this one as the Nk minus K plus 1 minus the Nk plus 1. So this one, it will be Nk minus a 2k plus 1 minus this. So you can see that this one can be cancelled. So everything can be cancelled in this way. So at the end, the first one and the last one is remain. Okay, so what are we having here is that we can write down this has become 1 over k of 1 minus a 1 over the nk plus 1. You can erase away the r equal to n minus 1 and also can erase away r equal to n. Okay, so this will be the series. Okay. You can leave it like that. Of course, if you want, you can actually combine them to become nk plus 1 minus 1 over the nk plus 1. Then simplify further. You can get n over the nk plus 1. This will be nicer. Okay, that will be the part A. Then we move on to the part B. They asking you to deduce the sum to the infinity. That means just need to have a limit of n go to infinity. So over here, for me, the sum of infinity over here, usually I will write like this. Kr plus 1, Kr minus k plus 1 is equal to the limit of n goes to infinity of the nk n over the nk plus 1. N over the nk plus 1. And for this case, at the end, you will get the answer as 1 over. You can actually divide everyone by n first. If you're not so sure, usually we can divide everyone by n. So if you divide everyone by n, then this is what you have. Then when the n go to infinity, 1 over n will become 0. So therefore, you get it as a 1 over k. Get it as a 1 over k. Done for the part B. Then part C. Now they are looking for the sum from n to n squared. So what you need to do is have to be careful. The sum of this series kr plus 1, kr minus k plus 1 is actually equals to the 1 to n squared of this. Minus the r from 1 until n minus 1. Kr plus 1 and then kr minus a k plus 1. So just use the result that you have in part A. The result that you have in part A. Now this n has become n squared. So if the n has become n squared, then just change the n here, just based on this result. Change the n to become n squared. Change the n become n squared. Then you get this one as a n squared k plus 1. Minus, now you want to change the n become n minus 1. So if you change the n become n minus 1, then you get this. Just like that. So actually, it's okay to leave it like this. If you refer to mark scheme, the mark scheme didn't combine them together. So you can leave it like this. That is the answer for the part C. Now we take a look at the question number 4. Question number 4, you have a matrix M is given by M equals to the A, B square, C square, and N. Then A, B, and C are real constant and B not equal to 0. Show that M does not represent rotation about the origin. Okay, so rotation. So in order to show that it's not rotation, first of all, you need to remember the standard formula, the rotations. So right here, the standard formula for rotation, you allow to memorize the result directly. So it will be cos theta, sine theta, negative sine theta, and cos theta. Okay. So this will be the matrix that represent rotation. Okay. So you can see that you can compare them in this way. You can compare this. You can compare them in this way. Oh, sorry. You can compare this, okay? So if you want to compare, then you can see by comparison, you have a C square equal to the sine theta and B square equal to negative sine theta, which means it will give you that the B square plus C square is equal to 0, okay? And because of B cannot equal to 0, that means C square must be negative, okay? Because this is add together to get the 0. That means for this case, both of them must be 0. B and C must be 0. But because the B cannot be 0, that means the C square must be a negative B square. And negative B square is a negative. So they are real numbers. They are not complex numbers. So this one, we need to ignore it. So therefore, M does not represent a rotation about origin. Okay, so this is the way for you to show it. Okay, so I write the conclusion over here. Therefore, M does not represent rotation. Rotation about the origin. Okay, so that is the how you show it. Then B, they want to find the invariant lines, okay, through the origin of the transformations in the xy plane represented by M. So to find invariance line, usually I will just do like this. Just write down the matrix first. Then the invariant line, because it's passed through origin, that means the invariant line is supposed to be y equal to mx plus c, because it's passed through origin, so the c will be a 0. So it will be just only mx. It will be just only mx. So this one usually I will write like this: x mx, then equal to the x, and then mx. Okay, then I expand them. I get a ax plus the b square mx equal to x, first equation, and the c square x plus the amx equals to the mx. Take the number 1, divide number 2, I get a plus b square m over the c square plus am equal to 1 over m. Cross multiply, you have am plus the b square m square is equal to the c square plus am. So am and am can be cancelled. That means the m can be positive, negative c over b. Okay, so therefore, your invariant line you have 2 of it. It will be y equal to the positive c over bx, and another one is y equal to negative c over bx. Just like that, that will be the answer for the part B. And move on. Part C. We have a situation here. It is given that M represents the sequence of two transformations in the XY plane given by an enlargement. Center at the origin, scale factor of 5, follow. That means this one, this is the first one, then followed by the second one. Shear, x-axis fixed at 1, 0, map to 5, 1. Okay. So over here, we have two matrices over here. We want to find M. So we need to let A represent the enlargement. So the enlargement scale factor of 5, it will be 5005. So this one, we just memorize the result for enlargement of scale factor K. Okay. Then B is the shear. Shear is it will transform 0, 1. Okay. It will transform 0, 1 to 5, 1. Okay. So it will be this 0, 1 to 5, 1. Then M is BA. You need to understand that this one is the first followed by, okay, the left hand side is the second one, the right hand side is the first one. So please remember. Then just write down the matrix, just show your result of multiplication. That will do. Okay, so this one B is a 1, 0, 5, 1. A is a 5, 0, 0, 5. Multiply them together. Your answer will be 5, 0, 25, and then 5. Okay, done for the C. And D. We have the triangle DEF is transformed by M onto the PQR. This is the object. This is the image. Okay. Then they say that given that the area of the object is 12, they want to find the area of the image. So we just need to use the result of the area of object is equal to the modulus of a determinant of the matrix M multiplied by the area of image. Okay. So over here, before we do this, we need to have a determinant first. So let me find the determinant first. Then I only use the result that we are having here. So what is the determinant of the M? So first of all, we need to find the determinant of M. It's the modulus of a 5, 0, 25, and 5. So it's actually a 25. So the area of the object, area of DEF, is equal to the modulus of 35 multiplied by the area of PQR, triangle PQR. So therefore, the area of triangle PQR is equal to 12. Oh, sorry, I put it wrongly. Yeah, I put the wrong relationship. Area of image and area of object, I do wrongly. So area of just now I write wrongly. Yeah, it's supposed to be area of image is equal to the determinant multiplied by the area of object. Okay, so just now I write down the relationship wrongly. So take note on that. So this one's supposed to be area of the triangle PQR and equal to the area of a triangle DEF. So that means this one, it will be 25 multiplied by 12, and then you'll get the answer as 300. So the unit is a cm square. We just write cm square. Done. Okay. Now we take a look at question number 5. The curve C has a polar equation like this for the data from 0 to pi. the first part of the question, part A, they want you to sketch the sea and state the polar coordinates of the point of the furthest from the pole. Okay, so first of all, if you have no idea how to sketch this graph, usually we can provide a table. One is the data, this one is a R. So the data is from 0 then until pi. So maybe you can put pi over 2 in between. If you're not so sure, you can add in a few more value. So over here, I think I just need to have 3 value with it. I just need to have 3 value. So I will have 0, pi over 2, and then pi. Okay, so you can just use your calculator. If you put 0 inside, you will get 1. We only consider R positive. We only consider R positive. So another one, it will be pi over 2 square. Just use your calculator. Then you square root it, 0.54. And this one is a pi square plus 1, 0.30. Okay. So that means in exam, you had to draw it properly with a proper scale. This is the theta equal to 0, theta equal to pi over 2. This is the theta is equal to pi. So when it's 0, you must have a proper scale now. So this is a 1, must pass through here. Then after that, your scale must have a proper scale. So this is a 1. This is also a 1. But this one is a 0.54, somewhere in the middle. Then this one is even lesser. So your answer it will be like this. Right, I'm supposed to draw from 0 to pi. Yeah, okay. So by right, the graph supposed to be like this. Okay, it's not a circle. It's not a circle, but when you draw it, it's like a circle. But in fact, actually, it's a spiral. Okay, actually, it's a spiral. But we don't need to show until 2 pi. We just need to show our graph until pi. Just like that, done. Okay, so this is the answer for the 5A. Now, of course, if you want, you can just put in here as a 0.54. Then you can put in here 0.30. But I don't think it's necessary. I don't think it's necessary. Because you have a table already, so it's fine. Then now, B. Find the area of the region enclosed by C, the initial line and the half line data equal to pi. Okay, so they are looking for this area. They're looking for this area. Okay, they're looking for this area. So how are we going to find this area? So what you need to do, just use a formula. So the formula for area, the half from 0 to pi, r square, d theta, just like that. Then just put in the formula for r square. Formula for r square is a theta square plus 1 d theta. So you can integrate this one directly from just refer to the formula table, MF19. Integrate 1 over tangent, 1 over theta square plus 1 is actually arctangent of theta, 0 until pi. And substitute the value inside, you have arctangent of pi minus the arctangent of 0. And just use your calculator. Now, your answer must be in radian. Please take note that your answer must be in radian. Okay, so just make sure you change your calculator into radian mode. If your calculator is in degree mode, then you have to convert it to radian mode, or you just need to convert it later after you find the answer in terms of degree, you convert to radian. So the answer here will be 0.361. Okay, done. That will be the answer for the part B. And now C. Show that, oh, sorry, just now I forgot one thing. There is a polar coordinate of the point of C furthest from the pole. So this is the furthest from the pole. So the coordinate furthest from the pole. Okay, the coordinate is 10. Okay, So this is something I forgot to mention just now. Okay, so now we go for the C. Show that at the point C, the furthest point from the initial line. So initial line is actually the x-axis. Initial line is the x-axis. Then we want to show this is equal to 0. Verify that this equation has a root between 1.1 and 1.2. Okay, so in order to show this, first of all, you need to understand that furthest from the initial line, this is the initial line. This is your initial line. So if you want to have further, the graph is like this, right? The further. So the furthest will be actually the y maximum. So to get y maximum, your dy dx must be 0. Okay, to get y maximum, your dy dx must be maximum. So, but your dy dx maximum means it's the same as the dy d theta and the dx d theta equal to 0. Okay. So that's in order to get dy dx equal to 0, you just need to focus to make your dy d theta equal to 0 will do. So there's no need for us to find dy dx equal to 0. We just need to focus on that our dy d theta equal to 0. But how do we get y? How do we get y? Our r square is equal to 1 over the theta square plus 1. You need to understand that the relationship between the polar and the Cartesian coordinate, it will be r cos theta is a x, r sine theta is a y. Since you want to get y, I just need to multiply both of them by sine square theta. Multiply by sine square theta. So multiply by sine square theta, I get this. Then this will be considered as a y square. And as I mentioned just now, I want to focus on the dy d theta equal to 0. So I have a differentiate here. 2y dy d theta is equals to differentiate this. This is a theta square. I write wrongly. So I need to keep the bottom product rule, differentiate the top, minus the keep the top, differentiate the bottom, divided by the bottom square. So for the dy d theta equal to 0, which means I just need to focus on my numerator. My numerator here, you can forget about the denominator. Minus this equal to 0. Okay, equal to 0. So now I just need to divide everyone by 2 theta sine theta square. Okay, so I divide everyone by 2 theta sine square theta. Then I get this. Divided by 2 theta sine square theta. So I divide the whole thing here, I get a 1. Then the 2 and the 2 can cancel, the sine and the sine can cancel, the cos over the sine. At the end, you will get this one as a theta square plus 1 over theta, and then cotangent theta minus 1 equal to 0. Bring the theta inside here, therefore you get theta plus 1 over theta, cotangent theta minus 1 equal to 0. Just like that. Okay, but we haven't finished yet because the question asking you to verify that the root is between, that means the theta is between 1.1 and 1.2. So this is equal to 0. Okay, so we just need to find what is the theta that will make this equal to 0. So if you can find the theta that make the whole equation equal to 0, that is called the root. So we want to verify that the root is between 1.1 and 1.2. So first of all, we let this whole thing as a theta, f theta, function theta. We let this whole thing here as a function called f theta. Then just substitute the value here 1.1 and value here, change the theta, become 1.1 and 1.2. So 1.1 you put in here, but this one is in radian mode. Make sure your calculator is in radian mode. Else your answer will be wrong if you don't put into the radian mode. So just press the calculator. That is one you can press yourself. So I just give you the result that I have from calculator directly. I get 0.226, and this is a positive value. Then this one is a negative 0.209, negative value. So that means that for 1.1 and 1.2, for 1.1 you are positive. For 1.2 you are at negative. So that means that no matter how you join them, there must be a line, there must be a point that will be passed through the zero. Okay, so therefore the root lies between 1.1 and 1.2. Just need to show that one positive, one negative. Okay, so you can see that the sign changed from positive to negative or changed from negative to positive. So we just say that because of there is changes of sign between 1.1 and 1.2, between 1.1 and 1.2. Therefore, the root, okay, there is a root. Lies between 1.1 and 1.2. Just like that, done. Okay. Okay, now we take a look at question number 6. The curve C has the equations y equal to the x squared plus 2x minus 15 over the x minus 2. Find the equations of the asymptote. So what we can do over here is we just need to find the vertical asymptote. Vertical asymptote, it will be just taking your denominator equal to 0, it will be x equal to 2. Then as for your horizontal, because this one is degree 2, this one is degree 1, so there will be oblique asymptote. There will not going to have any horizontal asymptote. So in order to find oblique asymptote, so first of all, you can do long division, but usually I will just do like this. Okay, I will just make it like this. Then this part, I take the x out. This one, I factorize it. Then this one, I will minus 8 minus 7. Okay, so this is what usually I will do. So after that, you can just simplify it. You get x plus 4 minus the 7 over the x minus 2. Okay, so therefore, your oblique asymptote is y equal to x plus 4. Just like that. That will be the answer for part A. Now, we move on to the part B. We want to show that it has no stationary points. So in order to show stationary point, we have to find dy dx. So the y, you can take the y from here and go and find the dy dx, or you can take the y from here to find the dy dx. So this one is highly recommended because this one is easier to differentiate. So I will use this expression. I will use these expressions of y in terms of x to differentiate. So I just copy it out. Now I dy dx, get a 1 plus the 7 over the x minus 2 squared. So you can see that if the dy dx equal to 0, that means the 7 of x minus 2 squared will be a negative 1. There will be no real solution. So therefore, your C has no stationary point. Okay, so that will be the answer for question number 6B. Okay, so now we move on. Based on the information given, we have no stationary points. That means the graph cannot be maximum, cannot have maximum or minimum. Okay, then we have two asymptote. We have the oblique asymptote, and then we have the vertical asymptote. Okay, but before we draw the graph, we need to find the intercept. Okay, we need to find the intercept. So it's better we spend some space over here to say that when the x is equal to 0, what is your y? So when the x is equal to 0, your y will be 15 over 2. And then when y is equal to 0, that means your x squared plus 2x minus the 15 equal to 0. You factorize it. X plus 5, x minus 3, x plus 5, x minus 3. Then you get x equal to -5 and x equal to 3. Okay, so these are the intercept. Okay, these are the intersections of the axis. So now we are ready to sketch a graph. So to sketch a graph, we use a proper scale, but because I am drawing it freehand, so it's a bit difficult for me to draw with a proper scale. Okay, so you are having 1, 2, 3, 4. -1, -2, -3, -4, -5. Then x equals to 2 is the vertical asymptote. Then your oblique asymptote is y equal to x plus 4. Y equal to x plus 4. 1, 2, 3, 4. So that will be your vertical asymptote. That will be oblique asymptote. So since your graph not going to have any, so usually when you have an oblique asymptote and have vertical asymptote, that means your graph is either will be here and here, or here and here. Okay, that means your graph, if you have 4 parts, either your graph will be these two, or your graph will be at these two sides. Okay, so these two is not possible anymore, because if your graph is at this portion, that means you must have maximum and minimum. Okay, since you do not have maximum and minimum, that means your graph can only be at these two sides. So your graph is at these two sides. So your graph will pass through the point 3. Your graph will pass through the point -5. And also you have a vertical intercept. This one we need to draw it properly. Okay, so what we need to do now, again, so in exam, we better use a ruler. We better use a ruler in order to draw the graph properly. Okay, so over here, let me just extend my vertical axis slightly higher. So this one is -4. This one is +4. Okay. Wait. Okay. So this one is 5, 6, 7, and 8. So this is 7.5. 7.5 will be 6, 5, 6, 7, somewhere here. So your graph will be like this. The graph will have a curve like this. Okay, so we need to draw properly. So in exam, please make sure you use a proper scale to sketch a graph. Yeah. So your another graph will be like this. Okay. So this will be the graph for the y. Okay. So just say that this is y equals to x squared plus 2x minus 15 over the x minus 2. Okay. Done for this part C. Now part D, they want you to find the modulus. So in order to do the modulus, just have a reflections. Okay, just that means this part, the one that you have with this portion, oops. This portion, it will reflect. And this portion will also reflect. Okay, so but we need to draw it in a separate graph. So just make sure you draw it properly. Okay, so let me draw again. Okay, so now over here, just modulus only with a proper scale. This is a 1, 2, 3 vertical asymptote. So over here, then 1, 2, 3, 4, 5, 6, 7, 8. Then -1, -2, -3, -4, -5. Okay, so 4 and 4. Oblique asymptote. Okay, so what you need to do now is just draw it like this. Then after that, this one reflect in this way. Okay, it will reflect in this way. Then after that, this one, okay, then it will reflect. This one continue. If you reflect, then it will reflect like this. Okay. So this one, it will reflect in this way. Okay, so this will be the answer. Graph for y equal to the modulus of x squared plus 2x minus 15 over the x minus 2. Okay, this is 15 over 2. So in exam, we still need to show this is a 15 over 2. Show all the value properly. Okay. So now E. Okay, so we still have part E. So part E is actually you just have this one out. 4x minus 30 divided by the x minus 2 less than 15. So you can see that this question, you can take a 2 out. Then less than 15. Then you can have this as an x squared plus 2x minus 15 over the x minus 2 less than 15 over 2. So means this is the graph in part C. Graph in part D, sorry. This one is a graph in part D, and they want it to be below the line y equals to the 15 over 2. So what you need to do now is just to draw a line 15 over 2. Okay. So you can draw a line 15 over 2 over here. So this one, if you extend, you can see that you have 1 intersect, 2 intersect, 3 intersect, 4 intersect. This one if you extend it. Okay, so you have total 4 intersections. You want the graph to be below. You want the graph to be below the horizontal line. So it will be this portion. Okay, it will be this portion. The answer will be this portion. So what we need to do now is we need to find the intersections, the intersections of the line and the modulus graph. Okay, So no need to show this in the graph. Okay, that's this one just explanation purpose only. Okay, so what you need to do now is split them. Just let this equals to 15/2. So if you let it 15 equal to 15/2, then you will have one positive and one negative. So you just need to solve the equations. You're just going to get a quadratic equations and then find each and every one, find the value x, then you will get the answer. So from here, you can just expand it. 2x squared plus 4x minus the 30 equal to the 15x minus the 30. So over here, this you can cancel it. You get 2x squared minus the 11x equal to 0. Factorize the x out. Then your x is equal to 0 and your x is equal to the 11/2. Then for this portion, you have a 2x squared plus 2x minus a 15 equal to negative 15x plus 30. Johnson is 30. 4x minus 30. So you have a 2x squared plus 19x minus a 60 equal to 0. So this one, if you cannot factorize it, then we just need to do the quadratic formula. If you can factorize it, then it will be better. So over here, we can factorize it. Then you'll get the answer x is equal to the 5/2 and x equal to negative 12. So based on the number line, arrange them in the ascending order. So you get negative 12, 0, and 5/2, 11/2. So remember just now I mentioned that the answer is at this area, at this region, and at this region. So therefore, your inequality will that fulfill the range of x that fulfill this inequality, it will be negative 12 to 0 and 5/2 to 11/2. Okay. Okay, so therefore that will be your answer that fulfill this inequality. Then done. Okay, so this is the answer for the question number 6E. Okay, now we take a look at question number 7. The plane pi1 has the equations as given here. So this is a vector equations. Then part A, they actually want you to find the equations of pi1 in the Cartesian form. Okay. So we need to convert the vector form into the Cartesian form. So in order to convert the vector form to Cartesian form, first of all, we need to find the normal vector. So this is a pi1. So I call this one normal number 1, the vector normal number 1, n1. So this n1, it will be, I think better we do the cross product first. So we take this directional vector, 1, negative 1, and 1, and another directional vector here, 1, 1, and negative 1. We do the cross product first. Then we can find that the answer will be a 0i plus 2j plus 2k. And you can take the factorize the common factor 2 out. Then we will use this as the normal vector. Okay, so from here we only write down this is a normal vector number 1. So therefore, the normal vector number 1 will be 0, 1, 1. Okay, then in order to find the Cartesian equations of a normal vector, just do the dot product. Here is a normal vector. This is a x, y, z, any random position vector. And this, the last one, it will be the position vector of 4, 0, -4, -3. Okay. Then just expand it. You get y plus z equal to -7. That will be the answer for the part A. Done. Okay, so now we move on to the part B. Part B, we have a Cartesian equation. We have a by 2, plane by 2, which is in the form like this. This is not a Cartesian form yet. Okay, this is also something like some sort like a vector form. However, the R over here is representing the random x, y, z. Okay, so what you need to do is actually just to expand them. You can actually convert the by 2 to become -5x. Okay, -5x plus 3y plus a 5z equal to 4. Okay, this is the Cartesian equations of the by 2. Now the question wanting to find the intersections, line of intersections of by 1 and by 2. In order to find the line of intersections of by 1 and by 2, we need to cross product the normal vector 1 and the normal vector 2. Then actually this is a normal vector 2. This is the normal vector 2, -5, 3, 5. So now I want to do the cross product. In order to find the directional vector of the line, it will be the normal vector number 1 cross product with the normal vector number 2. Just now the normal vector number 1 is a 0, 1, 1. This one will be -5, 3, 5. So you do the cross product, you will get this as a 2i minus a 5j plus a 5k. Okay. Then because the equations of line, it will be r equals to the a plus dp. So we already found the b. This is the b, the directional vector. Now I just need to have a fixed point a. So in order to get the position vector of a a, I need to solve the simultaneous equations of the by 1. The by 1, I write down here as a, just now is a y plus z equal to -7, right? I write this one down as a z equal to -7 minus y. So this will be equation number 1. Then as for the by 2, I have -5x plus 3y plus 5z equal to 4. I just need to let one of the variable to become 0. So usually I will let x equal to 0. You don't have to follow me because if you refer to mark scheme, I believe mark scheme will let the different variable to become 0. So this one, the answer will not be unique. However, I will let x equal to 0. Then I will get 3y plus the 5z equal to 4. Then this will be the equation number 2. So 1 into 2. Okay, then you get the 3y plus the 5z equal to 4 if you substitute them inside. Okay, then if you expand them and simplify them accordingly, you will get 2y is a -39. Then your y is a -39 over 2. And your z, if you substitute them inside the equation 1, then your z will be a +11 over 2. Let me check with the calculator. -7 plus the 39 over 2. Oh, sorry, 25 over 2, not 11 over 2. +25 over 2. Okay, so this will be the y and z. Okay, so from here, therefore, the equations of line L, it will be r equal to the 0, -39 over 2, and 25 over 2 plus the dp. The p will be 2, -5, 5. Okay, so please take note that the answer that I have here may not be the same as the answer in the mark scheme because this solution is not unique. Okay, what I mean is that the position vector that I have may not be exactly the same as the position vector given in the mark scheme. Okay, so but as long as it's fulfill the equations of the plane, that will do. Okay, So that will be the answer for the part B. Then part C. The line passes through the point A with the position vector AA and -7 is parallel. Okay, so a line L pass through the position vector and is parallel to this. A and B are positive constant. Then the perpendicular distance from A to the plane by 1 is a SAT2. Okay, so to find the perpendicular distance, we use a formula. So AX1 plus B X2 plus the CZ Y1 over the square root of A square plus B square plus C square. We will be using this formula. But the pi 1 just now, we have the pi 1 from part A. Pi 1, the answer, the equation of plane is Y plus Z plus 7 equal to 0. So what I need to do is just to write down here. It will be X plus Z plus 7, and it will be 1 square plus 1 square. And then they're telling you that this is a SAT2. So the D is a SAT2. So this point, it will be the point A. This is the point. So I just need to put in the A and A minus 7 inside. Just replace A and A minus 7 inside. Then at the end, I can get this answer as a 2 equal to the 2A, modulus 2A. Okay. Then because the A is positive, they mentioned that the A is positive. So the 2A is positive 2. Then the A is a 1, just like that. Done. Then now we move on. D. Given that the obtuse angle between L and pi 1 is 3/4 pi, find the exact value of B. Okay, so for line L, this line L is different than the one that we have here. This line L is the one that I find just now, but this line L is the one that's given in the question. So for the line L, let me write down. So since I know the A is a 1, so this one will be 1, 1, and -6. Okay, so it will be 1, 1, -6 plus the D of the directional vector. The directional vector, it will be 1 minus B and BB. So over here, 1 minus B and BB. Okay, this is what I have. Then they are telling you that we have the line look like this. This is the directional vector and the normal vector for pi 1. Okay, so we are looking, they are mentioning that the obtuse angle, this obtuse angle is actually 3 pi over 4. 3 pi over 4 means this is a pi over 4. So we can actually change my obtuse angle to become acute. Okay, it depends on how you want to do it. Okay, so it depends on how you want to do it. So maybe I remain my diagram over here. So I just take the dot product between the N1. Just now the N1 was, okay, I will be using this formula. The directional vector for the line, 1 minus B square plus the B square plus B square. Then this one is a 1 minus B, and then B. The normal vector for number 1 is 0, 1, 1. So this one is a 1 plus 1. Okay. So I think I will use modulus. Okay. Because the question giving you 3 pi over 4 is here. So I want to use obtuse angle. So I use pi over 4. So this one, it will be pi over 4. Pi over 4 means 45 degrees. That means this one also 45 degrees. So this one is also pi over 4. Okay. So this one, I just used it as a B plus B modulus is equal to the square root of the 3B square minus a 2B plus 1 square root of 2. cos pi over 4 is 1 over Z2. So this one can cancel off. So you square it both sides, you have a 4b squared equal to the 3b squared plus 2b plus 1. Then you get a b squared minus a 2b plus 1 equal to 0. This is a minus. Wait, I make a mistake. Minus a 2b plus 1. So I get this one as a minus 2b plus 1. So this one is a plus the 2b minus 1 equal to 0. Then I cannot factorize it, so I just need to use the dimension exact value, right? Yeah, dimension exact value. So I need to use the quadratic formula. Negative b plus minus square root of b squared minus a 4ac divided by 2a. So I will get b equal to negative 1 plus minus Z2. So because of the b is positive, therefore my b will be negative 1 plus the Z2. That will be the answer for the question number 7. And these are the last questions. I'll stop the video here.